Hi guys, welcome to Ian Neil Saturday Night Study Group, where we will be covering some of virtualization and then containers, and then I'll open the floor up for people to give me any open questions they wish. So the first thing we're going to do, we're going to go to virtualization. Now, what happens with virtualization? You need the infrastructure is your server, and this is where your storage is. So you've got your operating system's infrastructure. Then on top of the operating system, you've got a thin layer called a hypervisor. The type 1 hypervisor is one that's got bare bones, like Hyper-V, ESX, or Xen. A type 2 hypervisors tend to be used by a user, and it's using VirtualBox for Windows 10, VirtualBox for Windows 11. And then we're going to look at some virtual machines. Now, the virtual machines themselves, if I need 4 gig of RAM for a physical machine, I need 4 gig of RAM for a virtual machine. So they need the same amount of resources as physical machines do as well. So let me go onto my whiteboard because virtualization is like a party. Here we go. What is the name of the person that holds a party?
Host.
Host. So here we go. I'm bringing up my host. Now, normally, with a host with a party, you have beer, you got music, and you got food. So our host is going to have three things. He is going to have CPU cores. He's going to have random access memory, and he's going to have fast disk. Those are the three things that he needs. Now, normally, your disk space for virtual machines comes off a storage area network, and you need a fast connection. Now, what do I have first of all? I've got a hypervisor, because if I don't have a hypervisor, I can't run virtual machines. So on my laptop, if I want to run virtual machines on my laptop, I have to enable Hyper-V or the hypervisor on the laptops. Each laptop's got a different setting. Now, what's the name of the person that comes to a party? What do you think?
Guest.
Perfect. Here we go. You must be experts at this. Here we go. We've got a guest. When we talk about a guest, we talk about a Windows 10 or a Windows 11 virtual machine. Now, I've had lots of parties in my time, and there's always somebody that comes to the party that haven't eaten during the day, and they've been drinking too much spirits and things, and they throw up on your carpet, isn't there? There's always somebody that ruins the party. So the person that's going to ruin the party this time is an attacker, and his name is Big Bad Bob. And what is Big Bad Bob looking for? He's looking for a guest. He's looking for a guest that's maybe not patched. If I don't patch my guest virtual machine, what does that make it? It makes it vulnerable. Yep. So Big Bad Bob gets into the vulnerable virtual machine. Now, what he's going to do, he's going to do an attack, and his attack is called VM escape. And what happens here, he's going to escape out the virtual machine, and he's going to attack the hypervisor, because if he can take the hypervisor, there may be 2 or 3 hosts on the hypervisor, it takes them out. he could also attack the host. Because if he attacks the host, all the virtual machines, let's say the host has got 20 virtual machines, all those virtual machines are taken out. Or it may attack a guest. Now, if I've got a virtual environment and I've got 200 virtual machines, Big Bad Bob is going to employ somebody called Nmap. Because Nmap, he actually can give you an inventory of your whole network. And what would happen here, Big Bad Bob would be looking not for the Windows 10 person, he'd be looking for the SQL Server because he's after the credit cards. Or he may be after the domain controller because he's after creating accounts. Now, when he goes across your network, this is now known as east to west. As he moves across the network, that's called east to west. If it's north or south, he's leaving the network. Now, a good thing for forensics is I want to have a copy of my virtual machine in case something goes wrong. So a copy of a virtual machine is actually called a snapshot. And the snapshot is a copy of the virtual machine plus RAM. Now, random access memory is data in use, so it captures all of that. When I was teaching Skype, we had 23 virtual machines in 264 gig boxes for the students to use. Now, you might do lab 1 and use machine 123. You might use lab 2 and do 124. So what they want to do is after they do each lab, let's say we're doing lab 1, and I've got 123, I'm using those, I can roll them back to where the snapshot was. Now, another thing that's in the exam very heavily, I would say, is the sandbox. Now, what is the sandbox? The sandbox is an isolated application. And there's 3 reasons we use it. Number 1, for testing. Number 2, for patching. Because I would rather test all the patches on a non-production virtual machine. And the third one, which is really important, is because we think it's got malware. So if someone's got a USB with malware or they want to test it, they'll use a sandbox. The other thing that's in the syllabus under virtualization is VM sprawl. Now, what is VM sprawl? He is an unmanaged God, I can't even read my own writing. If I can't read it, what chance have you guys got? So he is actually unmanaged virtual machine. So if the administrator doesn't know he's there, he's not going to patch him. So things that are popping up and things that are really, really crucial is your sandbox, your snapshot, and your VM escape. These are the areas in virtualization that the examiner tends to focus on. So what we'll do, we're going to go for virtualization Mark II. So I'm going to clear this screen here, and I'm going to go for virtual desktop infrastructure. and he's known to his friends as VDI. Now, what happens here, I have got a pool of virtual machines. And here's A, here's B, here's C, and here's D. And they all have the same image, but the company, he installs the image. Because he installs the image, it's the same image, he's got total control over that virtual machine. Now, here is Fred, and Fred is going to use virtual machine A, but Fred is working from his home. And Fred is on his home PC that he shares with his children. What's the danger here? Oh, by the way, it's unpatched just to make it even worse. So he's got a crappy machine at home that he wants to come into my virtual environment. Now, normally we would say that that is very dangerous, but not in this instance, because we are going to use a thin client. Now, thin clients can be something like Citrix, but when he connects to the virtual machine with a thin client, all he's doing is mouse clicks and keyboard strokes. So really, when he looks at an image on his desktop, the image is actually over here. So there's no data going up and down. Now, if Fred is using machine A and he commits a crime, normally you've got Inspector Clouseau or somebody coming around to look at him. But if his virtual machine goes corrupt and he rolls on machine B, then the forensics people might not get the information that was in the corrupt machine. How's that? How are we doing with this? So let's go through and see what I need on my server. Here is my server. And the first thing I need a hypervisor. Why do I need a hypervisor? That lets you create virtual machines. How's that? Now, the next part, any questions so far? Right, the next part, I'm going to go back onto my slides, and we're going to see a similarity between virtualization and containers. Now, for my virtualization, I need hypervisor or hardware-assisted virtualization on my laptop. But each laptop vendor calls it something else. Then you can buy virtual machines, but each virtual machine's got their own operating system. Now, developers have been really, really happy lately because with the developer, they get the host operating system and they get a thing called Docker. So where the virtual machine needs a hypervisor, containers need Dockers. So let's go back and look at the whiteboard. And this is a part that a lot of people do not get. But I've got a new way of delivering it. Here we go. I have got our red machine, and in UK, it's called a fridge. Let me translate that for all you lovely American people. It's refrigerator. Okay? Now, on my fridge, I've got little cans. And these little cans are red. What do you know? What sort of sodas do you know that are red? They're coming in red tins, red cans. What do you think it could be?
Coke.
Spot on, Jeffrey. This is Coke. Now, I've also got on the shelf below it little cans that are silver. What do you think that could be, Jeffrey? If I've got red cans that are Coke, what are the silver ones?
Beer?
No, it's still soda. We're not allowed alcohol.
Right.
This is the Diet Coke. That's
Oh,
why you guys don't know it, because you don't take Diet Coke, isn't it? Because you don't actually drink Diet Coke, you don't realize it's Coke without sugar. So this is called my Diet Coke. Now, let's say I pick up a can of Diet Coke. Can I walk away and go on a picnic with that can of Diet Coke? Yes. And why is that? Because the manufacturers put it in a tin and it's got everything it needs. It's got the gas, the widget, it's got everything. Agreed? Now, what we're going to do with the Diet Coke, my wife has just brought a new fridge. And you can see that this is a blue fridge. Now, do we have to phone up the Coke people and say, I would like you to reconfigure my Coke so it works in a blue fridge? If you phoned up the customer service at Coke and says, look, I've got a red fridge, I've now got a blue fridge, I want you to reconfigure the Coke to go in the blue fridge, they'll send for the psychiatrist because they think there's something wrong with you. Now, how do you move the can of Coke from the red fridge to the blue fridge? Now, this is really complex. I open the door, I pick up all the Diet Coke, put them in a tray. I take the Diet Coke, whoops, they've changed. They can't change. I've got the wrong color. Here we go. So what we got, we put the Diet Coke onto here. And look what's happened here. I've now got regular Coke on one fridge and Diet Coke on the other fridge. Does everybody understand what I've done so far? So we're going to put this in to IT stuff with a thing called a container. So we're going to get rid of this and we're going to start off with a server. Now, this first server is not going to have Hyper-V. He's going to have a thing called Docker. Hyper-V allows you to create virtual machines. Docker allows you to create containers. Now, the one thing the developers like, they get their application and put it in its own container. So although it shares the operating system with the other containers, it's got its own autonomy. It's got everything it needs inside. And the developers love this because they can put application inside these new containers. You see it? I've got a red application. I've got a blue application. I've got a black application. Now, just like the fridge scenario, this one here, we'll make the black one linear. Now, what I'm going to do, I'm going to actually get a blue fridge over here or a blue server over here, and he is going to be Microsoft. Now, if I want to take normal applications and move them between Linux and Microsoft or Windows, I would have to reconfigure them. But we take the Microsoft server and he runs his version of Docker. And that means if I want to, I can just move the blue application across there. Now, these have got their own autonomy, but they're nice and small and light. So they've actually taken less of a footprint than putting an application in a virtual machine and moving virtual machines on. Now, the thing about the Docker and containers, it's not operating system sensitive. So it's not reliant on the operating system because it's got its own autonomy. Any questions? So let's go back to the slide with the container, because I've been teaching this every week since February this year, and people struggled with the containers. But you can see here, there's your host operating system, but it needs Docker. If it has Docker, we can containerize the applications. So inside the container, the application's got everything it needs, and we can move them from place to place. How's that, guys? Now, Jeffrey, what did you want me to cover, please?
The data tokenization and data masking, the differences.
Okay, then. Let's look at data masking. Now, they're both, they could be, no, we'll just go back. They're both going to be for credit card numbers. Now, if I've got a Visa card, I've got 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. And what masking is this. It masks the first 4 numbers, the second 4 numbers, the last 4 numbers, and what you do here, in here, you only see the last 4 numbers. So you've gone from having a whole credit card to there. Now, let me just make those last 4 numbers a bit better. Normally, my writing's better than this. So, when you go on Amazon and you're going to make a purchase in Amazon, and you've used more than one different card, it says to you, which one of these cards do you want to use to pay for? And you say, oh, I'm going to use 1, 2, 3, 4. Have you seen that before, Jeffrey? So that is masking. So it's very simple. What does masking do? It hides a portion of the credit card. I think in my book, I mask everything apart from the last 3 digits. But you're hiding some of the data inside the credit card. That's so that none of the employees can steal the credit cards. It just saves the company from a lot of grief. Now, the other one we're going to use is tokenization. So once again, I've got a credit card I'm going to store 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. But what I'm going to do with this, I'm looking for a payment gateway. Now, this could be Barclays. It could be somebody that does direct debits. And I'm going to swap the credit card for a B9 token. So my credit card, let's say this is Barclays. My credit card goes across to Barclays and they store it 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And I no longer have this. And they send me back 4, 5, 6. So they give me a token 4, 5, 6, and I store a token 4, 5, 6 in my database. So the problem with tokenization, if I want to retrieve the credit card, I've got to go to the payment gateway and say, here is my token 4, 5, 6. May I have my credit card? How's that? Okay. Okay. Then we had someone were wanting HSM. Is that correct? Right.
Yes, HSM and TPM.
That's okay.
Thank you.
Right. I've got a laptop. And what I'm going to do on my laptop, I want to do BitLocker. So I'm going to put BitLocker on my laptop. So before I can do that, I've got a chip that I put in my motherboard, and the chip is called a TPM. And what that does, that holds the keys for BitLocker. So if I go to BitLocker now, we'll get rid of BitLocker. I'm going to go to what they do in the exam. I'm going to go for FDE, and that's full disk encryption. So if I don't have a TPM chip on my motherboard, I won't be able to steal the keys. Now, when you reboot your machine, it does a measured boot. And if the TPM chip thinks it's been tampered with, it's going to actually get you to go for recovery. But one thing that's in the exam at the moment is if I want to save my data at rest, I need a TPM chip. Let me just bring up 3 types of data. I've got data at rest. This could be saved data. Example, my PowerPoint slides. So on my desktop, I've got my PowerPoint slides and I've got data at rest. And my desktop is actually BitLocker. So I've got a TPM chip on my motherboard to store the keys so that if I boot up the machine and it thinks it's been tampered with, it'll go into recovery mode. The other thing you've got to know is data in use. And every piece of data that's in use, example, applications, they run in random access memory. So my PowerPoint, when I open it up now, is no longer data at rest. He's now data in use. And that's why when the forensic examiner come, they use a forensic toolkit and they capture what's in the memory. And the last one is data in transit. And we're going to use a protocol called Transport Layer Protocol, TLS. Are we okay with a TPM chip? Right, I'll take another example. Here is a bank. And in the bank, you've got a teller. And I come in to the bank. I've got a nice red suit. I'm very thin because I've been in the diet. And I give the teller $500. So the teller's got the $500 in her desk. What happens when the bank is closed and it's time to go home? Do they get a carrier bag out and say, right, you're allowed to take all the money at your desk home with you? No. If they did that, we'd all have jobs as bank tellers. So where do the bank tellers put the money? They go to the back here and they've got a thing called a vault. You see that? And they put all the money into the vault. There's my 500, and she's got another 1 million. So she had $1,500,000 in her bank. So what we've got in the IT world, we've got a person called the key escrow. And in this world, there's a private key and a public key. And he holds the private keys for third parties. Now, he's going to be overwhelmed as well with all these private keys. So what he does, he stores them in a hardware security module. And there you go. All the private keys are actually stored in the hardware security module. Now, this hardware security module could be built onto the server. You could also use something like an external hard drive for that. as well. But the hardware security module is just to store the digital certificates. Any questions? Right. We seem to have done 50 minutes so far. So what we're going to do, we're going to finish the session off by looking at a few questions. But I've made them a little bit trickier this week than the last couple of weeks. Question 1. What is virtualization primarily used for? What do you think?
I'd say B.
Yes, it is. It is B. It's running multiple operating systems on a single physical machine. Now, when Server 2000 came out in 17th of February 2000, my job was to actually migrate people to Active Directory from NT4. And I would walk into a server room, and inside the server room, there would be 20 physical servers. And I'd look at the resources on them, and they would have something like less than a 1 gig processor, less than 2 gig of RAM, and maybe 500 mega disk space. So what we did, we reduced the physical machines by opening up 2 virtual machines, which are bigger and beefier, and each physical machine was a virtual machine. And we actually, if you think about it now with the cost of electricity, that would be a good move. What is the key difference between containers and virtual machines? What do you think the key difference is?
I think it's A.
The containers don't use a hypervisor. What did the containers use? They use a Docker.
Okay.
Virtual machines need the hypervisor. No, there's nothing wrong with it. This is for learning. Now, containers can't run in the cloud. Well, that's why they're invented. Virtual machines are faster than containers. No, containers are lighter and faster. But containers share the operating system, and each virtual machine has its own operating system. How's that? Now, let's look at another one. What is VM Escape? What does Big Bad Bob do?
Yeah, I would think it's B.
Yeah, a vulnerability where code is executed and interacts with the host. What's it doing with interacting with the host? It's attacking the host. That's what it's doing. Now, if you've got my booklet, I think everybody in the class has got, there's an exam voucher giveaway. It's announced the 1st of December. I will actually post it. If you don't have the link, just message me in LinkedIn and I'll give you it, because I'm going to give a voucher away to somebody. I gave 2 away last month. Let's go around the room. Jeffrey, how did you find the session today?
Excellent.
Kathy, how did you find it?
Thank you, Ian. It's very good as usual. I learned a lot. Thank you for the explanation of the HSM and the TPM.
Did you understand the explanation?
Oh yes, I love the way that you're able to break it down into, everyday usage of the bank teller and the vault. It's much clearer now.
That's good.
Thank you.
Nicole, how did your first session go?
I really liked it a lot. I liked your analogies. I thought it was good, very good.
Yeah, if you keep it to IT, it can get bored and people go to sleep. You know?
Yeah, yes.
Ed, how did you get on?
I totally agree. You made it way easier to understand with the analogies, particularly with the fridge and the party scenarios.
Yeah, the way I wrote my book is the way I actually teach it to the military and the corporates and that. So I got it because I can't teach every course in the world and that. But the book breaks it down quite well as well. Linda, how did you get on?
I loved your analogy with the two fridges today. That was an awesome description of Dockers.
Yeah. So what I need
Yeah, it
you
was a
guys,
good session.
right? What I need you guys to do, I need you to tell other people that these sessions are good and put something on your social media platform. Say, come to Ian Neil Study Guide, because I want it to be a study group. So I want people to be bombarded with questions so that I can actually answer the questions. So if you can, by next Friday night, just in-message me things that you're struggling with or things that are just not clear enough for you. You know what I mean? But for this week, I'll say goodbye, guys. Thanks for supporting me, and I'll see you next week. This is going to go onto YouTube tonight because I don't have to cut any bits of this video. Okay?
Thank you.
Thank you so
Thank
much,
you.
Ian. Have a great week.
Thank you, Ian.
You too, guys. But by the way, if you're studying and you're struggling with anything, just message me on LinkedIn because I can help you. I just want people to be the best prepared they can be for